Hi and welcome. This time around I have a really exciting tool to unbox here. It's a nice crate that it came in, and this guy also came with for free what's in that crate over there, which shouldn't be stored vertically, but I don't have any room in here and I couldn't leave it outside, so it's vertically for the moment. But this was an item that I have been doing all of my machining jobs for. Sorry about the motion there. And I finally was able to pick it up, and I figured I'd pick this up before the Chinese tariffs go into place. If you know, Trump does what he's promised, add 10 to 25% tariffs, that means everything from China is going to cost 10 to 25% more here in the States, which means this guy would have cost about $2,500 more. And thank goodness, because this also went on sale for Christmas. So the combination means I probably saved $5 grand over what the normal price is next year. So let's just dig in and open this up. I'm very excited about this. They did a decent job of packaging this guy up. Some nice heavy duty fiberglass bands. These are thicker than ones I normally run across. They're really stiff. Alrighty. Looks like they screwed the lid down. So I need to point out that not all of it is here yet. Some of it is being shipped from China, just an extra lens. Oh, so it's a box in a box. Okay. So along with the expected staples everywhere, we have these on all the corners, like 3 of these per corner, 2 on some corners. Can't decide how they figure that out. But in order to get this box out, it's kind of wedged in there. You have to pop the sides apart. No shortage of staples. Or brad nails. That was a lot of work. Holy cow, was that heavy. All right, moving on. There's the debris left over there. Now we're just trying to get in here. All right. Ooh, very nicely packaged. I like, this is super thick here. You can see my fingers. Well, you can't exactly. It's about inch thick cardboard. Well, if it's like that, it's only 3/4, a little over 3/4. All right. If you're interested in the company, there it is, Cloudray Industrial Solutions. They have shipping locations here in the United States. Turns out it's actually in Southern California where I'm at. Would have been fast, but FedEx took their time and misdelivered a bunch of times, so it took a while for me to get it. Wow, this is very carefully packaged. Okay. The name Cloudray might have given it away. Does anyone have any guesses yet? We're coming up on it really quick. That's a very nice package. I think I got to be pretty careful with this because I believe this is a fiber. If that doesn't give more away, which it should. Has feet. So this is the base. Look at this beauty. This thing's gorgeous. Box of accessories, safety glasses, and if you haven't guessed yet, it is a Galvo fiber laser by Cloudray, and I've been looking at them for a long time. They seem to make a high quality item. They're more expensive than a lot of them that you can find on eBay. They use JPT lasers, and this is a MOPA 100 watt. Let me get all the rest of this out and we'll put it together. Last piece out of the box, motorized Z height. All right, so in the box, let's see, it comes with a guarantee. Comes with guaranteed power out, 104 watts, supposedly tested with a QC. Then they have a handwritten QC, which I like. Looks like JPT tested it themselves and printed this out. Cloudray went and verified this. So that's really good. Nominal output power, they got 107.7. So they said it's better. Like so many of these things, everything you need to assemble it. USB drive, Kingston, so a nice one. I'm not sure what that's for. Not sure what those are for yet. Here's some screws. Here's a drive with the software on it with a key. Came with screwdrivers, locking, USB, power, foot switch, safety glasses. Don't ever operate a laser without safety glasses. Nice. Oh, some engravable business cards. That's cool. Bunch of gloves. RS-232 to USB. Oh, USB to serial adapter with drivers. Although Windows should recognize it automatically if it's not a rip-off Prolific chip. Yeah, Prolific put in their current drivers a test for fake chips, and if they detect a fake chip, they disable the driver, which is kind of a bummer because a ton of these adapters that come from China do have fake Prolific chips in them. Anyways, that's a side note. All right, so I've assembled this guy really quickly. It was only a few screws. Everything went together perfectly. The fit and finish was fantastic. Came with a couple spacer bars to align your parts on the base plate. Right now, these front feet aren't touching anything, which means we're probably sitting on the stepper motor and back because one of the feet raise it up enough so the stepper motor, which sits down a little bit, doesn't touch, but I can't fit it on this table very easily. Here's the galvo head. And I'm not sure why they have the long tube. There may not be anything in there, or there might be a lot in there. I'm actually not entirely sure. I think the whole laser assembly is in the base unit. Let me get that up here. So I think the laser is inside of here with the power supply. It's a fiber laser, which means they use a doped fiber to actually be the lasing medium, which is advantageous because then the light is traveling straight down the fiber and you can direct it where you want. The galvo head has a collimating lens on it. The lens that comes with this is, if I remember right, 175 by 175 or maybe it's 100 by 100. You know, it might be 100 by 100 millimeter, which would be roughly 4 inches by 4 inches or 125 by 125. Let's see if I can find that spec. I forget. I ordered a lens that was 200 by 200, which would give me an 8 by 8 area. One of the reasons I got the 100-watt laser is so that, number one, I could engrave deeply and potentially cut. On top of that, I wanted to be able to do larger areas. And when you spread the area, obviously, the power goes down. So this Z-lift control, all the connections are in back of this guy. So this is the laser fiber out. There's a foot switch, a rotary adapter, which I did buy, Z-axis, which is this, which I will hook up, and protective cover, which I'm not sure, maybe that's this protective cover. Underneath this galvo head are 2 lasers right here and here where my fingers are, and they point down at the table here, and when the 2 are pointed at each other and they meet at one dot, which would only be for one specific focal length, then the laser's in focus. So you preset these up, and maybe they set this at the factory. We'll find that out when we go and calibrate that. The advantage obviously is because if your part's sticking up off the table, then this has to go up to compensate, and that laser focal distance matters a lot, because if you got to imagine all that power, you want to squeeze it into the tiniest spot possible. The more out of focus it is, the more that laser energy is spread out, because the light is doing this, and once it reaches the point of focus, it'll start to diverge again on the other side. So if you're either side of that focal point, you'll get less power out than this is capable of. So here's adjusting focus. If these 2 lasers, this one and this one, are correct, so they will come together at a point when this is supposedly in focus, like so. Now, if they're set up right, they may not be set up right. We're going to have to check that later. So the software was pre-configured, so you figure it'd be working right out of the box, but actually nothing worked right out of the box. So let me show you some of the problems I had, but first I gotta exit out of this. All right, so when I got this guy, it came with this zipped file and this folder on this Kingston, you can't see it over here, that Kingston 2 gig drive, USB drive, tiniest thing I've ever seen. And all the software is pre-configured in it. So all I did was make a copy of it, because the EasyCAD doesn't have to be installed. You just run out of whatever directory it's in. So I copied out of here, I copied the software directory out of here onto my desktop so that I had a copy of it, so any changes I made wouldn't be permanent. They have manuals in here, but it's not what you think. They aren't in depth by any stretch. There are no good, as far as I can tell, EasyCAD manuals from the manufacturer. Like they'll say, here's a feature, this is the light burn wobble, and it enables the light burn wobble without ever telling you what that is, and there's no explanation. So half the options in here, you're just guessing at what they mean, which is really unfortunate. Anyways. Next thing you need to do after you've installed this guy is you plug the USB cord from the controller in, and if you go to your device manager, you can just type in, if you don't know how to get there, you can type in from here, control panel. I'm in Windows 11, type in control panel and then select device manager. So control panel, I have a shortcut on my desktop, and go to device manager right here, not devices and printers. So when you go to device manager, you're gonna find that this says this driver is not working and it won't be called this. So what you need to do is you need to double click on that driver, and since it's not working, it's gonna take you to this page, and you can choose update driver. And when you choose update driver, you go to browse my computer, and then you browse to the folder that came with this guy. And if I remember right, let's see, is it here? I think it's software, yeah, on driver. And you just point to DLC USB folder there and hit OK, and it'll replace the driver with, well, what Windows, so when you get a new device, Windows tries to go online immediately and find the driver. Well, actually, it searches the main computer first. Then if you tell it to search instead of browse, it'll go online and look for a driver. But the best way to do it is to take the driver they've given you. And once you select that driver, then your laser mark control board is working, and then the software sees it, and that's just the beginning of your problems. So when I ran this software the first time, all it did was have nothing but crashes saying file not found. Bad data in file, bad data in file. So this thing is constantly posting errors, and finally, if you can get them to go away, when I finally was able to get them to go away, I went to parameters F3, and under field here, there's use the correct file for calibration. They have a calibration software on here, and it helps you calibrate dimensions of where the laser is going. The galvo is not perfect, and so you give it a calibration file, and you can make it so it's square, and that 10 millimeters is 10 millimeters, or an inch is an inch. And so there was already a calibration file created. This was set to true, but there was no file in here, and so it just lost its mind. And so again, you can either make this false and go run the calibration software. So you could turn that false. Let me leave this for a second. And under software here, there's Calibration Wizard. And then you can run this Calibration Wizard. Again, doesn't need to be installed. Calibration Wizard right at the top. And what that will do is let you make some measurements. And it looks like, wow, looks like there's probably some Chinese characters that aren't quite right, and same here. That's great. So it lets you measure from here to here along the axis, from here to here along the x-axis, 6 to 5, 4 to 5, 7 to 8, 9 to 8, and then vertically 1 to 2, 1 to 4 rather, 2 to 5, 3 to 6, 9 to 6, 8 to 5, and 7 to 4. You put all those measurements in here. It creates a calibration file, although look at that. I can't read any of this because that font is not right. That's great. And then it also lets you correct for bow. If the galvo is non-linear, so it's curving in or out, that is concave or convex, parallelogram or trapezoidal, and you can fix all those, except I can't read any of these, so that's a little disconcerting. So that wizard's not going to do me a whole lot of good. I didn't actually try it because they already had a pre-made file for me, thank goodness. Maybe you can download another copy of that. So let's go back into EasyCAD. Okay, so I didn't close this out all the way. So let's go back to parameters. So the first thing you got to do is set this to true and then point this to the file. And I'll show you that in that folder, desktop software, calibration wizard, there's 2 files. I chose 9-point correction and it seemed to be pretty good. And you'll see the results in a second. So after you've done that, then the next thing is I canceled out of this and I said, you know what? Let's see the red light, because there's an internal visible laser that, so first you got to draw something. So let me just open the file I was using here. There's my test. That was the first one I created. I just did a square and a barcode and filled it in with a hatch. Oh, I never saved the other one. Okay, interesting. So anyways, create a barcode, filled in a hatch, just see how that would print. This is pretty thick, all this black area. Everything black gets cut out. That's over here with pen number 1, or number 0, I guess. And that all gets cut out. If you want to create one on your own, you can create something really basic right off the bat. So I could draw a square, and I could draw it anywhere I want. Then you got to go up here to select it. This is EasyCAD 3, EasyCAD's 2 different, and I don't know it. So I start with position, just select it all. We'll make the center of the square the center, so I'm going to tab 0 and 0. And then let's make the square 20 millimeters. Currently I'm in metric, 20 millimeters. And it centers it, makes it center and makes it 20 millimeter. Then I could put, for example, a circle, and we could make that one coincide. So I go up here and select the circle, and I could make it centered on the center, and tab takes you between these fields. And let's make it the same size as the square so it becomes tangent, and say apply. There we go. Oh, and that's because symmetry is locked and I didn't draw it as a square. So if I unlock this, then I can make it anything I want. That lock right there. Hit apply. We should be right. Okay, I'm very new to this, so I am by no means an expert. You're almost learning as I'm learning. So then to create a black area, right now these lines will be cut with the laser, the black lines you see, but just for interest's sake, it was suggested that you group all these parts. So like these, you group them so that when you hatch them, this H up here, there's lots of options for hatch, and I just took the default. I definitely have not experimented much with this. There's a ton of different hatches. And I guess you can create your own, I don't know. Oh, there's some different kinds of hatches right there. You see, that's how it's gonna fill in the area. All right, so let's leave it on that one. And just say okay. Oh, that's interesting. Last time it didn't do that. Let me undo the hatch. Maybe I didn't quite group. Yeah, it is grouped. Sure, because when I chose the barcode, it just went around the object, no problem. There's obviously something I need to learn about the hatch that I don't know. Okay, so now I have this. So I want to turn on the red light. The moment I turn the red light on, it's working on mine right now because I fixed the problem. But it says, I need to home. And when I told it to home, I have a motorized Z-axis. It would run the motor and crash. And it wouldn't let you do anything. You couldn't manually position up or down. It would automatically say need to home first. And the moment it tried to home, it would crash the head because I guess there's no limit switch or my limit switch isn't working. I'm not sure. I sent an email off to find out. So what I did was, to make this work, was I went to parameters here, and after a lot of fidgeting, axis solution here, set for Z and A axis. A axis I believe is the rotary. I'm not 100% sure. But I scrolled down here and went to home and set this enable to false. If you turn limit switch on or software limit, that didn't help you. It would say run out of x-axis range. It would crash the head. So in one direction it wanted to home, the other direction would say out of x-axis range. Now basically what homing does is it'll take the head and drop it to a sensor like a limit switch and stop there. And now it's got a reference point where everything can be referenced from. So it's a really handy feature to have. So either the limit switch is broken or there isn't one on this because it does not work. I tried up and down, didn't matter, it just crashed every time. So I turned it off. So what I did, so by turning it off, I disabled it up there, and I disabled, this was also true, limit switch was true. So since they pre-configured this, I figured that it was right. And if you're wondering how I know they pre-configured it, part of this is because the laser type was in here, the min and max value for frequency was in here, and a bunch of settings. They knew that it was a JPT. So all those things in here were set already. And so I figured this configure. Now maybe I'm wrong. Maybe I was supposed to configure this from the get-go. They don't really say that in the instructions, and the instructions they do come with are pretty weak. This is the basic manual for putting this guy together. Cloudray Light Marker Laser System User Guide. And they go through steps, and they've got my MOPE over here. Pulse width 2 to 500 nanoseconds. I wonder if that's in the software. I should check that out, because you can use this to populate those tables. And I should double check it, because maybe they didn't pre-configure it and I'm just guessing. So I don't know. They tell you, you know, where to hook everything up, sort of. They just define it. They don't really tell you where to hook it up. Installation, they tell you the screws, which were fairly obvious. The best way to put the galvo head on here is to rotate to the side and line up. They've got T-nuts in here that slide around, and just line them up vertically with the slots here, and then turn it back down, and you can rotate it side to side to get them lined up, and that seemed to work. By the way, like this one shows, you have a manual handle, but once you hook the Z-axis up, you have to turn the laser off. That would be the second switch. So there's 2 power switches on this guy. Let's see, where they show that. There we are. Whoops, one too many. So there's the emergency stop. So you twist that and let it come out. That means everything's enabled. Turn the controller on, and that's good. Then once you turn the laser switch on, that enables the stepper motor for vertical, as well as all the laser. You can hear the fans come on, everything come on. In order to manually adjust with the height knob, you have to turn the laser switch off. Then you can rotate it anywhere you want, turn that back on again. I couldn't find a way to disable the Z-axis other than maybe in software, which you could probably do. And I didn't try that. And I don't know, because this, you know, the solenoid, when it's not moving, it's in a hold. And they tell you how to do the driver here, which I had done the driver myself already, but there's step-by-step instructions here, which are pretty good. They did a good job on this. And they even tell you how to uninstall the driver if necessary. They tell you can just copy the software onto the disk. They tell you how to, oh, there's another thing I forgot to tell you about here. You have to activate the software. And I figured that one out on my own too, because it's pretty straightforward. So if you go to the EasyCAD folder, which is under software, and EasyCAD, let's see, EasyCAD, release, there is a license manager. You start the license manager, and that key that I showed you, that USB key, there's a code on it that you've got to enter. And you enter that in License Manager, and then you tell it to go online, so you got to be connected to the internet, and it'll enable that license. I forgot to tell you about that. Sorry about that. That's another thing I had to do. But they tell you here in these instructions. Then they tell you to set, under parameter 3, choose true, but you've really got to zoom in to see this, because they don't actually tell you what you're setting to true. That was too much work for them, apparently, to use words to do that. This manual really needs to be done. And that is that calibration file that you need to set true. It's supposed to be defaulted false according to them, but it really isn't. And that's the one that causes the thing to go nuts. When it thinks there's a calibration file but it can't find one, there's no error checking in the software, and the software just loses its mind. Set your workspace setting. That's based on the lens 110 by 1. That was all pre-configured for me, which is another thing that led me to believe it. Half these say, this focus position, say, okay, we can go back in the software now and I can explain some things that, how you use this when it's not set automatically. So let me close this, open up EasyCAD. So now what you do is, So I have my safety cap on right now. And right now, actually my height is already set. Now they calibrated, under here are two visible lasers, here and here, that are separate from the one inside the galvo. And these two are helping you to find focus. So you can see right now, that they're not focusing. And let me just pull them farther apart. So when those two dots overlap, this is in focus. But however, if your unit does not become pre-calibrated at the factory, then these guys will not be set right, and you have to go through a whole nother procedure. I recommend you search online for setting that. You basically run the laser continuously, and you keep moving focus until it makes a really loud sound and starts cutting really well. You'll see it and hear it. It's really interesting how audible this laser is when it cuts. And so mine was pre-calibrated from the factory, and it seems really close. So what you do is you move your Z height. And by the way, the software, if you click too many times on like an arrow button to move this thing down, it'll queue them up. It doesn't react very fast. It takes like 2 seconds for each move, which is poor feedback if you ask me. Okay, so now you can see that's in focus as a single dot. When I take the safety cap off, which you should always have on when you're not actively using the laser, so that you don't accidentally damage your eyes, because the light coming out of this laser is infrared and invisible. It's not red, it's infrared, past your ability to see it. And if you get a reflection off of this surface here, and it gets you in the eye and you're not wearing your safety glasses, you'll permanently lose your, damage or lose your vision. So don't mess around with it. So there's another dot in here right now. You can see there's 3 dots. If I come up here, this one's the galvo dot, and these are the other 2 dots. And you see as I come down, it's closer to focus. Once you've told it to find focus, you need to set your focus position. So set current position to focus position. Now, anything you put on that plate to be engraved is going to change the height of this focus position. You always need to do that first. And then, once you've set your, and let me tell you the reason for that, because once I tell it to mark, which is actually to have the laser cut, it's going to move to whatever this focus position is and wait there and cut. And if you get it wrong, then it's not going to cut right. It'll be out of focus and there'll be no power and it won't cut because the beam will have diverged too much. So the laser beam, if this is the laser head up here, coming out of the lens, the laser light is converging on a point. Once it reaches that point, it'll diverge on the opposite side of that point. This point is where you take all that energy that's out here and you squeeze it to the tiny point. The smaller an area you can squeeze that energy, the more it's going to cut or etch or whatever it is you're looking for. Once you've set your focus position, you're ready to go. Let me throw just a piece of material down there. So the first thing I'm going to do is I'm going to turn on red. Okay? And that is tracing out the outside of the box. And this helps you line your part up, right? Before you cut anything. Let's just set it over here. And actually on camera, you can see that this is not continuous, that this is cycling. With my bare eye, it looks like a solid red box. So that tells me exactly where the laser is going to cut if you've set things up right. Okay, so now before you cut, you can leave it on default parameters here, but over here is how you control how much power the laser is going to be. And it's associated with each one of these pins. So when you do a hatch, you choose the pin you're interested for the hatch. So you can have a bunch of different laser settings, so you can have it darker or lighter or deeper cutting or shallower cutting, or just marking very gently and not really etching deeply into the surface at all. So by default, the software has used default parameters, which speed is 1500 millimeters a second or 1.5 meters per second for the galvo, how quickly the laser light moves. The slower it moves, you can imagine that energy is going to stay in one place longer, you cut more. Frequency. On mine, it goes from 1 to 4,000. And I do not understand all the variations and how this all plays in, but the frequency is basically this laser light is always pulsed. It's not a CW laser, which means stands for continuous wave. It doesn't work that way. It pulses. So you got to choose the rate at which it pulses. So at 4 megahertz or 4,000 kilohertz, this is in kilohertz, It's pulsing very quickly, and here it's 75 kilohertz, it pulses slowly. Here's power at 50%. Interestingly enough, in the manual, they don't tell you this elsewhere, and I'm going to tell you now, this is interesting. The manual warns you. So this is a 100-watt laser, right? If you go over 75 watts, they say you will significantly reduce the life of your laser. They don't tell you how, why, or anything else. They just say, oh yeah, you're going to reduce light. So in reality, if you want this thing to last the potential 50, 100,000 hours, you're never going to go over 75 watts. So that makes this a 75-watt laser in my book, not a 100-watt laser. Sure, you can get 100 watts out of it, but if I get reduced life expectancy, I don't know what that means. And the laser is the most expensive part of this whole thing. So I don't want it to die. So I found that sort of amusing. But you can't make changes on any of this. See, if I try and change this, it won't let me. That's because you've got to change this up here from true to false. So what I'm going to do is I'm going to reduce this power down to 10%. And I'm going to take the frequency up to 400 kilohertz, or let's make it really light. Let's make it 4 megahertz. I think that should make it pretty low power because it's pulsing on and off continuously a lot of times for things to cool down. And let's see what this does. So to start the etch, I'm going to hit mark over here. First, you use the red to line up your part, then you hit mark. The laser safety glasses. Things to know. Look for this engraving up here. It tells you what wavelengths of light this thing blocks safely, at least in this case OD6, which is how the optical density 6. These guys here fit over my glasses. That's one thing to pay attention to because I wear glasses, and the ones it comes with don't fit over glasses, so I ordered these on Amazon. If there's a scratch in this film, it won't be protecting your eyes anymore. You've got to throw them out. All right, I'm going to run the camera through the safety glasses as well because the camera also has a sensor that's very sensitive to infrared and it can be damaged as well. And let's just show you a quick low power trace. Let's see if you can even see it. That was it at 1500 millimeters a second. If I slow that down to 150 millimeters per second, and you can hear that, right? So passing over the same area can be controlled. You can tell it to do a number of loops. You can tell it to go over the same area. So there's loop control here, which tells it to go over the same area more than once before it stops. I manually had it go over those areas, and I had to raise the power so you could hear it and see it. So I made it 50% at 400 kilohertz. I could have just done something really thin and light, like maybe some black paper or something like that with the low power, but I didn't have any handy. What I etched probably is going to be barely visible, but there you go. Actually, at 50% power, that's really deep. I ran up here. This is wobbling, which the laser light wobbles, and you can control it following a path, how much it wobbles and how far it wobbles. And it did, I don't know if you can see that, but it ended up doing similar to what the welding guys use for welding. This one, I tell it to go over the same area 4 times, and it cut so deeply, it almost cut all the way through the part. On the back here, I've got a Dudley Toolrite symbol, and the metal bent. It got so hot because I went around it a lot of times, and it moved. Either that or I bumped it. Finally, here's a piece of steel, and I etched this one. This one came out beautifully. This one is so deep that your fingernail gets stuck in it. I'd say it's a good 10, 20, 30 thousandths deep. Pretty impressive, actually. That's really deep. Did a great job. You can even see that fine outside line, which is the minimal thickness of the laser, I believe. If not, it's probably pretty close to it. That's just amazing. And you can feel that with your fingernail too. So the quality is really good. Here's another thought over here. While this thing is, the laser is cutting material out of the part, all of that material that it's cutting out by superheating it until it evaporates and then it explodes out is going to go somewhere, and that somewhere is the air. So make sure you've got proper ventilation. They sell air cleaners. What I did was I sucked through the vacuum cleaner. I put the vacuum cleaner right here, which might have been how I bumped that one part, and sucked the particles as they came off. That worked pretty well, but I'm not sure that the filtration on the vacuum is good enough to protect my lungs from the smallest particle. They may go right through. If that's the case, then I need to do something about that in the future, so I might have to end up buying their air filtration system one, or maybe take the output of the vacuum, either run it outside or put it through a HEPA filter of some kind. So I'll work on that in the future. There is so much I don't know about this that I can't begin to give you a decent in-depth study because I don't understand it well enough myself yet, but I can get it to have some pretty decent results, like this guy here. And this was just playing for a very short time. I'm trying to catch the light just right for you. And the quality is surprisingly good, so I'm very happy with that. The quality of the machine's great. The documentation is horrible. And I'm not sure about the Z-axis. I'm still in an email chain with China. By the way, their responses when you're buying something are fantastic. They shipped it immediately, like within the next day they shipped everything, and they shipped stuff out of China using UPS, and they only charged me $10 for all the shipping, so it's built into the price. They were very good about that. So I have nothing but good things to say about that. I think the language barrier is causing us the most issues here, and you buy a system like this, I guess you know you're getting into that to some degree. Just for information's sake, I looked at a 50-watt system like this from Hewlett-Packard for work to engrave walkie-talkie batteries and walkie-talkies. And that 50-watt system is a 100-watt system. That 50-watt system from Hewlett-Packard was $56,000. This one was 20% of that, less than 20% of that. It was like 80-some hundred on sale. So I think it was a great deal, and I will play around a lot more in the future, and I will take you along with me as I go and as I learn more, and hopefully I can give you more information. Thanks for watching. Hope you find it useful. Hope to see you next time.